Okay, this lesson, all 6 trig ratios, but this time we're only going to give you 2 of the sides, so you're going to have to find the third side by using the Pythagorean Theorem. So we're on lesson 4 for the week. Got some examples here. So same process. I am going to identify the hypotenuse, the adjacent side is the side attached to the hypotenuse at that angle, and the other side is the opposite side. And then label your sides. We got hypotenuse, opposite, adjacent. We need, in order to write all 6 trig ratios, we need to know the length of the adjacent side. Obviously it's shorter than 7, and you can tell with your eyeballs that it is bigger than 4, so it's going to be in the 6 range. Let's see. So Pythagorean Theorem says that the small side squared plus the medium side squared is equal to the hypotenuse squared. So a squared plus b squared equals c squared. I always, if I have the choice, I'm going to call this the small, medium, large. I almost always do it that way for consistency. If you do something the same way every time, less likely to mess up. So small side is 4 squared. The medium side, we don't know the length of it, and hypotenuse is 7 squared. And then you evaluate. You get 16 plus b squared equals 49. And then you subtract 16 on both sides. Now we're only giving you 6 problems because obviously these require more math, more skill. And then square root both sides. Now technically, you learned in the quadratic unit first semester that when you square root both sides of the equation, you get a positive and a negative answer. But since we are dealing with a geometric figure, we are going to ignore the negative answer. Alright, we do not know the square root of 33, so you're going to leave it as a radical. So the length of this side is the square root of 33, which my estimate before we started was somewhere around 6, and this close. Square root of 33 is like 5.8-ish. Let's see, square root of 33, 5.7-ish. Now, when you're dealing with trig ratios, the word ratio means fraction essentially, right? So we do not want decimals here. So you're going to leave it as a radical, a simplified radical if possible. And like I said, I'm going to attach to the module a video on how to simplify radicals just in case you forgot. Here we go. Sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent, which we now know is square root of 33 over hypotenuse. Tangent of theta, opposite over adjacent. Now, some books, some teachers, some professors say it's perfectly okay to leave a radical on the bottom of a fraction. I'm also going to show you what to do if your teacher or professor says it's not okay, that you have to, something called rationalizing the denominator, because square rooting usually leads to a rational answer. So you're going, or irrational answer, you're going to rationalize it and make it into an integer. It's not that hard. I will show you later. Cosecant is the reciprocal. Secant is the reciprocal. But for this lesson, for my students, I'm perfectly happy if you leave it like that. And then more advanced lesson, we'll have you rationalize denominator, simplify radicals. Flip that upside down. Voila. Another example. So on this example, we knew the hypotenuse. On this one, we do not know the length of the hypotenuse. So it's a little bit different. And adjacent side is wherever the reference angle is, it is attached to that angle. The hypotenuse and the adjacent side always are attached to the reference angle, or the angle in question. That's the opposite side. So we got opposite, adjacent, hypotenuse, and we need to use Pythagorean Theorem to find the length of the hypotenuse. A squared plus b squared equals c squared. I always go small, medium, large, so 2 squared plus 6 squared equals, we don't know the length of the hypotenuse. You could use c or h, whatever variable you want, technically. 2 squared is 4, 6 squared is 36, 4 plus 36 is 40, square root both sides. I probably on this problem should have showed canceling. So squaring and square rooting are opposite operations, so they cancel each other. Squaring and square rooting are opposite, so they cancel each other, and you get positive, negative, radical 40. I'm going to leave it like this for this lesson, but just keep in mind this particular one is simplifiable. That one was not, and I'll talk about in the next video how you can tell if something's simplifiable or not. Anyways, now we know the length of the hypotenuse, square root of 40, which is like 6 point something. You know the square root of 36 is 6, and square root of 40 must be a little bit bigger than the square root of 36. So 6 point something. Square root of 40. 6.3. So the hypotenuse is a little bit longer than the adjacent side in this situation. And now that you know the hypotenuse, you can write your 6 trig ratios. I'm going to go real fast. Opposite over hypotenuse. 2 over radical 40. Cosine. Adjacent over hypotenuse. And tangent. Opposite over adjacent. That one's easy to reduce. Cosecant. Flip it upside down. Secant. Flip it upside down. Flip cosine upside down. And cotangent. 6 over 2. And in the next video, I'll show a couple things: how to simplify this radical, and then what to do with radicals in the denominator. And there you go. There are only 6 problems in this next assignment because, it requires a little bit more work, a little bit more skill.